right now, but I still have, what is it, like 6 more people to get through today. I have to listen to them tell me about their lives. And I get to judge whether or not they get to stay down here with me for eternity or go up there with the big guy. So let's get started. Oh, Mr. Dalton, it's great to have you here in hell. My name is Lucifer, and today I get to decide if you go to heaven or stay down here in hell with me.
Huh. Why would I go to hell? Let's see, a little bit about myself. Well, you already know my name. I'm a chemist. I was born into a poor Quaker family. I was a teacher myself at New College in Manchester. I did several things. I contributed to the law of multiple proportions, Dalton's law, color blindness, atomic theory. Do you need to know more?
Well, it says here that you actually designed an atomic model. So can you tell me how it worked and how it contributed to human scientific discovery as a whole? Any good, any bad?
Okay, let's see. Oh wow, you actually have my model here. Okay, that's good. So there were things before me that really helped me in making my model. There was a law of conservation of mass and the law of definite proportions. So I used these two laws as a foundation for my model. So I was led to the theory when I was looking for an explanation for the law of multiple proportions, which is again one of my contributions. So I was wondering why water absorbs different gases in different proportions. So if you have water, it's going to absorb carbon dioxide much better than it's going to absorb nitrogen. So I hypothesized that this was due to the differences in mass and complexity of the gases, respective particles, and this hypothesis led to the atomic theory, which can basically explain in 5 points. Elements are made of extremely small particles called atoms. Atoms of a given element are identical in size, mass, and other properties. Atoms cannot be subdivided, created, or destroyed. Atoms are different elements combined in simple whole number ratios. And in chemical reactions, atoms are combined, separated, or rearranged. So in this picture, that's a oxygen atom, and these two are hydrogen atoms, and which combine to form water. So the oxygen atom has a mass of 16. The two hydrogen atoms have a mass of 1. So the water has a mass of 18. And that's basically it.
Well, it sounds like you've done quite a lot, actually.
I know, I've done a lot.
Yeah. So this is your ticket.
Oh.
You get to go upstairs, talk to the big guy.
Yes.
Let's see who's next. This guy named J.J. Thomson, who developed the plum pudding atomic model. Lots of physicists today. Welcome, Mr. Thomson.
Yes, hello, where am I?
Hell.
Hell?
Yeah, basically, you tell me, Lucifer, what you've done in life, how you've contributed to society, and I judge whether or not you spend the rest of eternity sipping pina coladas on a sunny beach in the celestial equivalent of Honolulu, or with me here in hell.
Thank you for having me. Just jumping right into it, in my life I lived in Cheetham Hill, England, and my father was a bookseller who planned for me to be an engineer. When he couldn't find an apprenticeship in engineering, I was sent to Owens College at the age of 14. Eventually, in 1894, I began studying cathode rays, which I guess you could say are glowing beams of light that follow an electrical discharge in a high vacuum tube. Through these rays, I discovered all matter is made up of tiny particles that are much smaller than atoms. I call these particles corpuscles, although they are now called electrons. My discovery upended the prevailing theory that the atom was the smallest fundamental unit. So in 1904, I introduced the plum pudding model, which...
Okay, but can I ask, why plum pudding? What is plum pudding exactly?
Well, that's funny actually. I call the model this because, to me at least, it resembles the raisins in English plum pudding.
Oh, that's really interesting. Okay, shall we actually move back to the topic of your model? The studio in sublevel 53 printed out this picture for us this morning. There may be a bit of goblin bile on it, but I think it should be safe to carry. Can you explain to me what the components of this model do?
Why, yes, I can. As you can see, these are the negative electrons scattered throughout the uniform sea of positive charge, and that's my idea of the atom.
Oh, thank you, Mr. Thompson. You pass. This is your ticket
Much
to
appreciated.
heaven. I'm so good at my job. Rutherford.
Hi, I think that you're looking for me. I'm Mr. Rutherford. Where am I?
Welcome to hell. Tell me a bit about yourself.
Okay, so basically, I was born in 1871 in New Zealand, and I am known as the father of nuclear physics. And I conducted most of my studies in England.
It says here on my transcript that you actually earned a Nobel Prize. Well, I guess people know you best for your gold foil experiment. Could you tell us about it? Because I honestly have no idea what it is past the fact that there was like gold and foil.
Okay, so basically, I chose gold because it's an extremely malleable metal. So I made a small, very, very, very thin sheet of gold foil that was 0.000004 centimeters thick, and I bombarded this foil with particles, and I found that only 1 in 20,000 particles were actually impacted, and the rest went straight through the foil as a bullet would go through a bag of sand. But the very small percentage of particles that didn't go through the foil got bounced back at a very high angle, which proved that that an atom has a nucleus. So I was the first one to discover a nucleus, and I also discovered the protons.
That's really interesting. I hope that's everything. Your time for
Model.
today is okay. Oh right, this was sent in by the studio. God, I'm so tired. Right. So this is your model of the atom. Can you
This
tell
is
me
my
how
model.
it works?
This is the model that is still used today, even though it's technically not right, but whatever. But basically, there is a very concentrated mass in the center of the atom, which is the nucleus, and it's positively charged because it has protons, which I discovered again, and then electrons orbit this nucleus in this fashion.
Cool. This is your ticket for the big man upstairs.
Oh.
It's second elevator
Big man.
on
Is that Neil deGrasse Tyson? Just
the
kidding.
left.
I think it's God.
Goodbye. Next up we have Niels Bohr of the Bohr model.
That's me. You must be Lucifer.
No, but he's an intellect. I can work with that. Hello, Mr. Bohr. Today I'm going to decide whether or not you belong down here or up there. Tell me about yourself.
Well, I won the Nobel Prize in 1922 for physics. Besides that, my full name is Niels Henrik David Bohr, and I was born October 7th, 1885 in Copenhagen, Denmark. Also went to Copenhagen University.
I see that you've also created an atomic model. Can you tell me about it?
I would.
Would you please tell me about it?
I developed the Bohr model of the atom, which I proposed that energy levels of electrons are discrete and that the electrons revolve in stable orbits around the atomic nucleus but can jump from one energy level or orbit to another. So here's my diagram, which looks like solar system because like the sun's in the middle, and then like these are the levels of atoms, and
Who is he showing?
that's about it, yeah. And these like represent the amount of the different levels, yeah. Okay. Yeah.
Thank you for your time, Mr. Bohr, Mr. Bohr. This is your ticket. Go see the man upstairs. Elevator 2 on the left.
All right.
Yeah, so I'm Heisenberg, right? I'm German. I was born on December 5th, 1901, in Würzburg. I went to school at the Maximilian School in Munich in 1920 to study physics. The model that I created is the theory of quantum mechanics model. It ties in with the uncertainty principle. I discovered that in 1925. I was only 23, which is pretty impressive.
Okay, my name is Schrodinger. I was born in 1887 in Vienna, Austria. I'm a theoretical physicist and I study electron movement at the University of Zurich. I worked as a professor at the University of Berlin in 1927. I left to work at the University of Oxford in 1933, which is also the year I won the Nobel Prize. In 1926, I created the quantum mechanical model of the atom. My quantum mechanical model is based on a quantum theory which says that matter has properties associated with waves. According to quantum theory, it's possible to know the exact position and moment of an electron at the same time. This is known as the uncertainty principle, which was created by Werner Heisenberg. I extended the work of another scientist, Louis de Broglie, by incorporating the de Broglie relation into a wave equation and creating the Schrodinger equation. Since we don't know the exact position of an electron, I use mathematical equations to describe the chances of finding an electron in a certain position. My atomic model doesn't define the exact path of an electron, but only predicts the odds of the location. As you can see here, my model can be shown as the nucleus surrounded by an electron cloud. Where the cloud is the most dense, you have a high chance of finding electrons and a low chance of finding electrons in less dense areas. However, my model doesn't completely discredit the Bohr model. The Bohr model still holds true for some atoms and is still used today due to its simplicity.